Good morning, all. Good morning. Man, this is quite a pumping tune, isn't it, for first thing in the morning? Press the magic face button and see how the camera's looking. Hello! Well, I thought that I'd best get back on stream at the earliest opportunity, given how busy I've been with work, and there's a very small window of opportunity today, which is why I thought, bugger it, I'll just do a stream at 8:30 for 90 minutes or so and see what we can get done. Apologies for being a little bit slack on the stream thing. It's not something that's by choice. But welcome to those people who are here paying attention. Thanks for joining in. I'm hoping that we'll be able to get some overlap with the folks overseas, given that I'm streaming at a different time of day. Obviously, Ruination, you are one of them. We don't get to see you too often, mate. It's lovely to have you on board. Bitwise, you're a regular. You're here pretty much regardless of the time of day. Talk about supportive. Anyway, I will stop babbling about nonsense and we'll get stuck in pretty quick. Just make sure you have your tea ready to go. I have my litre of Gyokuro ready to go today. No dark chocolate for me though, because it is only 8:30 and that's an unhealthy breakfast. Now, yeah, grab some coffee for sure. So the plan is not to follow on immediately from the last stream. When we finished off streaming last time, we were implementing the exit windows functionality, and there were a couple of quirks to do with manipulation of tokens. And I put that on ice and said, hey, we'll finish that off next stream. I'm actually not going to do that today. We'll come back to that another time. Instead, today, what I want to start working on is support for the HTTP transports. Something just a little bit different. I know that means we're kind of spreading ourselves a little bit thin, but I think there's enough in that to, get started and dive deep into some stuff before we actually go headlong into supporting channels. So that's what we're going to do. Now, let's get VMware up. Let me know if the audio volumes and whatnot are not right. But I think they're okay given that nobody's complaining. Either that or nobody's listening. Which is also fine. Alright, so. Music's a little bit loud in my ears. I'm going to turn it down just a little bit. There we go. Music is a bit loud but not problematic. Alright, let me just wind it back just a tiny bit. I think it's one of those songs that maybe just has a little bit of a higher vox level. Let me know if that's terrible. Okay, so as you can see, we've already got some transport related bits and pieces in here, one of which is this HTTP transport. Now we've implemented a subset of parsing for this, for configuration and whatnot, but we don't have anything in here that actually does communication with endpoints and all that sort of thing. So there are two things that we're going to need to do. The first one is create like a fake stager, just like we did with the TCP. As you can see, we've got the simple TCP stage test. We need to do something very similar to this, so that we effectively have a staging shell, and that can connect back to our listener. And then we need to go and fill out the actual body of the HTTP transport. But in order to even get to the point where we can do that, we've actually got to have Metasploit be aware of the fact that we've got HTTP/HTTPS related transports on the other side. Which means we've got to go down the rabbit hole of doing things in Metasploit. Now, if you remember, we have a number of different things that we need to do. We've got to create a stage, we've got to create stages, and we've got singles which we can worry about down the track there, the stages payloads. So to start with, we're going to go into stages, and you'll see we've got CLR2 and CLR4. Now we'll start with the CLR2 one, and then we'll just do a very easy port. Okay, so we've got reverse TCP, which looks like that. Now what I'm going to do is take this and a copy of the reverse HTTP one from Windows and merge the two. So if we take a copy of, let's take a copy of Windows reverse HTTP http.rb. Put that here. And then we'll gvim all the things. Okay, so we have a look what we got here. There's not really a lot of shenanigans that we have to worry about. That's too different. Command shell and command shell options. I wonder why these are actually in here. We might not actually need these, but I might come back to that anyway. So let's quickly go through here. Windows reverse. We'll call this a CLR2 reverse HTTP stager. Maybe we'll call it a reverse. Yeah, no. Let's leave that as CLR2, and we'll get rid of this WinINet thing because that has no relevance to us. Ton of communications over HTTP. CLR2 author. That would be me. Now, does the author thing, is it an array or is it not an array? I've never really been 100% certain. I think it supports both. Platform is Windows. Now, am I actually right in writing Windows? I see Win and I see Windows. Let's have a look. Yeah, right. See that? It shouldn't be Windows, it should be Win. That's good to know. Let's fix that. So that should be Win. Hey, Zarubis, Aracon. Thanks very much. Mind turning the volume up a bit? It's a bit difficult to make you out. Okay. Is that with compared to the music? Hey, Eric. Thanks for coming in then. Is it because the music's too loud, Aracon? Is that what the issue is? Because the voice is actually up as high as it can. Let me just bounce that bit up. How about that? Tell me if that helps. Yeah, that's better? Okay, cool. Thanks, dude. Sorry about that. No worries at all, man. No worries at all. Okay, so while we've got this open, let's change that to Win. And we'll have to remember that we need to do that for the other stuff that we've done as well. So that's going to be Arch CLR2. Payload Windows. Now this is going to be CLR2. I don't think we actually need to have Payload CLR2 in there. We'll probably just have CLR2, and we'll include the reverse HTTP stuff. Payload CLR2. And that's pretty much all we have to do, and we may not even need that convention, but we'll see. Might keep this consistent, bring that in line with super. Yeah, it's a bit strange, hey, how like every time I fire this setup up, I haven't changed anything, but I always seem to have to tweak a voice level of some kind. It's strange. Okay, so this grep actually implies that we've got another issue. Let me just quickly go into CLR4 for a sec. Did I do it? Yeah, I did. Okay, let's just quickly fix that. Now, I'm pretty sure I don't need these command shell and command shell options, but I'm going to leave them in there for now. OBS adjusts RNG for sound settings. Yeah, that's exactly right. I'm using Streamlabs OBS at the moment, and I'm wondering if that has the same magic as anything else. All right, so I think that should be okay as far as our payload goes. So let's go up into stages. CLR2. Now we don't actually have to modify anything in here, do we? Because these are pretty much the same. But what we do need to do is change the payload, the reverse HTTP payload, which should be in cd libmsf4 Now there's CLR 2. There's reverse TCP. Okay, so if we just have a look at that, what do we got in here? Ah, yeah, okay. This is where it starts to get fun. So, alright, so let's take a copy of the Windows one. And let's have a look at all of the reverse things. Okay, now we don't need block API and we don't need exit func. Pretty sure we didn't have that either. We've got UUID options in here. Do we use that in? We don't use that in here. That's okay. I'm going to keep hold of it anyway, in case. Now, stage a URI length. I don't think we're going to worry too much about the limitations, but I think I'm going to, for the most part, leave this as a fairly hefty copy and paste. Because we basically want to support all the things that the original one supports, with some tweaks. So when we generate this reverse TCP, for example, sorry, HTTP, we're not actually generating any payloads at this stage, any content at this stage. We're actually going to be serving up something completely different. I've got a new follower, Izzy McGill. Thank you for the follow. It's very kind. Okay, so if we look at what we did, we have a generate reverse TCP. You see, this is where the stage of payload goes. And I'm going to do exactly the same thing here, because we aren't at the point where we're actually able to generate .NET stages yet. But we will be getting to that down the track. So this is where I'll put HTTP stage at payload goes, and I'll change this so that we know. Call it CLR2 even, just to make sure that when things get spat out, we can see that we haven't filled gaps in. Okay, now this generate URI UI mode native, we're going to have to change this to something like CLR2, because we want remember our URIs encode a bunch of stuff, including architectures and things like that. So what I'll do is I'll change this to a new init mode, which will be init CLR2, and then behind the scenes we'll have to change the UUID related bits and pieces to support, including the new architecture. We may actually be able to abstract that enough into just CLR rather than CLR2, but it is what it is. Now this required space stuff doesn't actually apply to us. We can get rid of this because we're not using any of that. ASM reverse HTTP, now we're not going to be doing this at all either, so we can get rid of that. Excuse me. Still got this niggling cough. Thanks to the illness that I had a couple of weeks ago. But thankfully it's not that bad. We will leave all the other settings as is. Now this required space stuff will probably end up changing as well. That's something I think we need to sort of fix across the board, to be honest. The required space is effectively hard-coded. We're not actually generating that on the fly or figuring it out on the fly. One thing that I think would be interesting to ponder for those people interested in the future of this payload is just how should we go about generating stages on the client? Is it good enough for us to use something like a mono installation? Or if we're running on Windows, so we just use the built-in compiler that's sitting on Windows, like, rather than actually try and generate MSIL ourselves. I don't know. I don't know what we can do there. But it's certainly worth pondering. Okay, so with that out of the way, let's just go to back to the root. Oops. And we need to achieve in local. Now you see what I did in here is I'm just spinning up. I've got a couple of native ones, and I've got CLR2 and CLR4 listeners. We're going to do the same again, but this time we're going to reverse HTTP, and we'll put that on So what I'm going to do is just try and spin up this listener. And see what it does. It might not work at all. I'm guessing it's not. It'll probably go, oh, you've missed the thing. And there you go. Please see. Oh yeah, I should be tailing that, shouldn't I? Oh, let's do that. B. Let's do that in here. What have we got here? Failed to load you the following error. Name error. Initialize constant payload CLR2. Oh, that's a silly mistake. Code, Metasploit framework. As you can see, was working on the blue keep stuff behind the scenes. Metasploit framework. Payload, no, modules. Payloads. CLR2. Reverse. Is that right? Oh yeah. Stages. CLR2 reverse HTTP. Yeah, so CLR is C with a lowercase r. Let's try that again. Still the same. Let's tail dash out this. Ah, yeah, okay. I also missed out on, what was it? This, renaming this. This isn't payload Windows reverse HTTP, this is CLR2 reverse HTTP. We probably should, while we're here, modify the UUID stuff as well, yeah? So that should be in, where are we there? Lib. I can't remember where the UUID stuff is. Where are we? Where are you? Here we go. Core payload UUID. There's so much stuff everywhere. Payload. Does that mean we're already in the right one? Yeah, here we go. Okay, so we've got CLR2, CLR4 in here already. Now we just need to figure out exactly where that function is called, right? Generate this TCP, generate URI, this thing. Let's take a copy of that and find it in here. UUID options, which actually makes sense. Colonel Smith, welcome. Lovely to see you, mate. You are definitely quiet compared to other sound inputs on my mic, even with the Twitch UI volume all the way up. Just means I get surprised when I see it. All right, let me turn up the volume a little bit more on the microphone again, and tell me if that makes a difference. It does look like something's changed. Hey, even on my side, it looks like something's changed. Okay, try. Let me know if that's any better. Maybe I'm too loud now. Definitely louder. Excellent. Because everyone wants a louder me. Am I right? No, I'm not right. Okay, so where is this? Here we go. Mode, URI checksum lookup. Is that in here? No, we got an ag for that. Let's take a copy of that. I'm gonna sneeze. Excuse me. Sorry about that. Where is this? URI checksum spec. Oh, we're going to have to add some tests as well by the looks. Meterpreter URI checksum. So, let's edit URI. Hang on, what did I miss? Def Rex. Oh, it's librex. Whoops. So we need to go Metasploit framework librex. Oh no, I need code in there. Code Metasploit framework librex payloads Meterpreter URI checksum. Here we go. Alright, so we now need to just add a couple more. Let's add one in here. Init. We'll call it C2. I don't know which numbers to choose, to be honest. Maybe I can just make one up. And then we can take this URI checksum to init C2, and that's CLR2. And we'll come back later and we'll add CLR4 later on. Now I don't even know whether that as a value is legit. I can't see why it's not. But is that all we need to do? I'm pretty sure that's all we need to do. Because that's the only reference we've got, let's say, to init Python. Ah, here we go. So there's some documentation that I can add. Init CLR2. Okay. Let's give that a go. Well, look at that. It's Pierce. Pierce has made an appearance. How lovely to see you, sir. Thank you for joining in. And yeah, Ruby. Man, work that Ruby. You know, it feels, I feel the pain when you say those words. All right, so we have a reverse HTTP handler. But that's not all of the work that we have left to do. We actually need to modify some of the actual handler code. I think that is in CLR. Don't mind me, just gonna lurk while you work. No worries. Thanks for lurking while you work, Benators. I hope you have tea. Make sure you have tea. Okay, so I'm going to close that because I don't think we need that anymore. I don't think we need the options anymore. Or the UUID stuff anymore. That should all magically work. We'll keep reverse HTTP open. But we do need to look into code Metasploit framework libcore. Is it handler? Lib MSF core handler reverse HTTP. Here we go. I knew it was in here somewhere. Okay, so all of these options remain true for all of the HTTP handlers. Now I just want to make sure that what we've got in here is legit, because I know there's a case where we actually analyze the URI that comes in and we do some routing based on that URI. So let's just figure out where that is. I think it's in here, but I might be wrong. Create session. This looks like a PDF. Init connect. Init Python, native, init Java. Okay. This is for process the required result. So this is when we receive a connection here, right? So on request. Yep, on request is when we actually get the new connections come in. So think we just need to add a case here. There's an else case here as well. So yeah, we need to add let's add it in init CLR2. Now self.generate stage. This is where it's going to get fun. I'm just trying to remember where this stuff gets wired in. Nicely put, Josh. Nicely put. Everything else in here seems to be pretty much exactly the same. It's the generate stage thing that's going to bite us just a little bit. Now, I don't know where that's going to come from. And reverse. So let's just quickly look for that. Def generate stage lib. Ah, lib NSF core payload. So we would need to do something. Oh, do we need to? Hey Rick, thanks for joining in, bro. Okay, payload single. This is one of the things that's I'm a little bit hazy on. And we've actually got some MSF devs in the room as we speak. So if anyone out there is aware of where this stuff needs to be, then sing out now, because it would be very beneficial. I'm trying to remember where the generate stage stuff ends up, because I know we need to wire it in somewhere. We may well have already done it to handle the TCP case, but I don't think we have. So we call self.generate stage, and reverse HTTP I assume is wired into sessions or handlers or something, and then one of these gets invoked, which ends up in one of these things getting invoked. But you see there's no generate stage here for Python yet. When we look at the handler, and when we get Python payloads, we still call generate stage. So plus we also need to be able to generate URIs on the CLR side. Inherited, certainly. Yeah, definitely inherited, but from what? Handler, reverse? I would have thought that ag would have told me of all of the references. So we've got generate stage in lib. Do we actually? Oh, is that part of modules as well? Is that? There we go. That makes more sense. Makes way more sense. And we should already have a stages CLR2, but we don't, do we? Single stages. There's our answer. Alright, so let's open up modules payload stages and see what we get in here. Edit. Framework modules payloads stages CLR2 Meterpreter. So we end up with Meterpreter loader. I'm pretty sure that has a generate stage in it, doesn't it? So out of touch with the code base now, that makes me sad. Me too. And I'm, you know, I look at it a lot more. It's crazy. Let's have a look. Okay, so what I'm going to do is I'm going to get get the code that generates URIs to generate me a URI. Because we're actually going to need to do that on the transport side anyway when we add new transports. But yeah, right now we need a URI that we can use, which will identify this as a CLR2 payload. Wolf has come in and he's resubscribed for the 5th month in a row. You are a legend, my friend. Thank you very much. Forgot to set your alarm clock. That's hilarious. You haven't missed out on much, mate. It's just me babbling. So we're currently working through HTTP transport implementation, just so that you know that's where we're at. And we're just wiring in some MSF related bits and pieces. So let's do this. Actually, you know what I'm going to do? Let's go MSF Venom, Payload, CLR2, Meterpreter, reverse, HTTP, lhost equals. Now I'm just invoking this to see if it would work, by the way, because I'm going to try and get it to spit out a URI for me in a filthy way. Let's just see what this does. Ooh, big decimal is. There you go. See that? This is where the CLR2 HTTP stage payload goes. So that's basically where we will end up generating the CLR payload from. But we need to. Where was it? Generate URL. Here we go. So I'm going to get it to spit it out here. Let's do this. Generate URI. Excuse me. I'm going to go generate URI. So that's just going to invoke this. I should comment out that previous line so that Ruby doesn't complain. So that should invoke this and return a URI that we can wire in manually into our payload. Pierce, are you seeing this, my friend? This big decimal being deprecated? Is that something that's already covered and I just need to update gems? Probably is, hey? Bearing in mind I haven't actually merged master into this for quite some time. But anyway, it looks like we've got what we wanted. There's our URI. So, when we go in here and we actually start working on static void simple HTTP stage test, we will have a URL. And it will be not that, because I accidentally got it off the clipboard. Copy. It will contain that. Cool. I am current. Cool, man. Thanks for the heads up. I had a feeling that you would be across that anyway. But cheers for that. It's lovely having you guys here. I can just reach out. It's like you're sitting right next to me. I can just reach out to you. var host equals. Okay, so our host is going to be the same as this client connect TCP option here. Port equals, what did we say? 4448. And we'll go scheme is going to be, for now, HTTP. Okay. So then our URL is going to be string.format of, we're going to have scheme first, followed by host, followed by port, followed by URI. That makes sense, doesn't it? Host, no, scheme, port, host, URI. Hello, Insolent. Good to have you on board, man. Yeah, early stream. I've been a bit busy over the last few days, and I thought, why not squeeze one in this morning and possibly overlap with some folks in the US. So here we are. And I'm feeling a little more alive. Like, doing it at night is actually really draining. So it's kind of nice to do it during the day. All right, so that's effectively what we're going to connect to now, yeah? Buster B. The warning, Buster, is this. This big decimal.new is deprecated. So we need to use big decimal, the method, instead. I would fix it in PR, but you know, streaming at the moment, so I can't. But yeah, you know, if you want to do that, legend. How cool is Buster? Brent is a legend. Brent, Pierce, the Rapid 7 crew are fucking awesome. I love those people. They're such awesome humans. And it's very sad that they live such a long way away from me, so I can't catch up with them more regularly. Do it! Do it! Okay, so, alright, so we have our URI. Let's continue working on the basics of this stager. Now, I think to begin with, what we'll probably do is a very simple web client based approach, and we will be using things like proxies. So let's start with this. Equals new system.net.web client. Now, to begin with, we're going to be getting probably like an octet string, like bytes. So we can go download data. Data, you like the way I say data? And we want to specify the URL. That's basically it, right? And once we've got the stage, we basically want to do the same thing as this. Now, we've got a byte array here, yeah? So after this, we can go static void load stage, and we're going to have a byte array that we are loading the stage from, and that would be basically this stuff here. Oh, hang on a sec. Ah, yes. We also need to remember, in the case of a TCP client, we actually pass it through, but in the case of a web client, we don't really care too much. But I'm thinking that maybe we'll pass the web client in. Like, we can continue to use the web client from the stager. The thing is, though, that in the case of a web client in a stageless scenario, yeah, I don't know. Maybe we can effectively do this. And then we can take this stuff. Yeah, let's take this out. Put it in here. Do the cheeky reformat thing. Instead of full stage, we have bytes. Instead of TCP client, we have client. And then here we can just go load stage, full stage, and TCP client. And then in the case where we have our stage here, we can just go load stage, stage, and give it the web client, which could be pre-configured. Hopefully it's that simple, right? But that does mean that we need to add something more to the server here, because when we bootstrap, see how we currently have there's TCP client. Let's take another copy of that. And what are we putting in? System.net.web client. Now, we want to do exactly the same thing as this, but instead we want a, excuse me, system.net.web client. Transport as HTTP transport. Now we need a wrap method for that too. Now this could probably be done a little bit smarter, like we could do the visitor pattern or something crap, but for now I just want to make it very clear and very obvious what it's doing. So that would mean, now inside here we're going to have what is effectively a web client reference. So we're going to have a private system.net.web client. We'll call it web client as well. Public void wrap. And then we can just go this dot web client. I'm pretty much certain that that's all the TCP transport does as well, right? Wrap. It does a little bit more because of the way that it works, but other than that we should be in a good spot. That at least gives us the ability to share a pre-configured stager. And this is one of the things that has been a little bit, I don't know, quirky in the native world. And when you look at the way things like the PowerShell payloads work in PowerShell Empire, there's kind of no information shared from the stager to the stage. So one of the issues that I had with PowerShell Empire in the early days, which I still have local code for, I haven't PR'd, is that the stager can get a subset of information and configuration, and that invokes the initial web request to reach out to the server and pull down the stage, but then the stage effectively doesn't have any of the context or information around the stager. And so you get to the scenarios where the stager actually works and connects, and then as soon as the stage starts going, nothing works because the config's different. And we've kind of got that to a point in Meterpreter, at least in Windows Native, but we do a good job of passing the configuration along. Now in the .NET world, we don't have to worry so much about that. If we can pass a reference to the web client that is already configured, we can just continue to use that web client for downloads. And that means that if the stager works, then you would assume that everything after that would work because it's reusing the same object that's already configured to work, if that makes sense. Does that make sense? Do I have any questions about it? Tell you what, I've nailed the brew this morning. It is an absolute cracker. Hopefully Rick is listening to that and is very jealous, but holy moly, it's good. Everyone's dead quiet. I must be doing such an awesome job of explaining myself that no one has any questions. Makes sense. Excellent. Love it. Love it. Okay, so what happens when we build this right now? Right, so what I'm going to do, I am going to spin up the TCP version of this to make sure that we haven't broken anything, because I've done this load stage thing, right? So let's just spin this up. Look at that. No connection could be made. The target actively refused. Have I killed off my... Yeah, I have. Who can I blame for my incompetence? There's got to be somebody else out there that can take responsibility for this. Alright, cool. We've got our handlers. Just want to make sure the TCP one actually works. Yay. Oh, that's a win. So now we'll change this so that we're not using TCP. We're going to use HTTP. Now I will add proxy support and whatnot to this, but for now, let's just see how we go. So this is hopefully where we're going to start seeing things behave the way that we had expected. Okay, so our URL, does that look good? Whoops. I put port and host instead of host and port. How dumb. Somebody else's fault for that as well, I'm sure. You guys are supposed to be my wingmen. 192.168.146.156, port 448 HTTP, and there we go. There's our URI. All right, let's see what happens. Ooh, look at this. What do we got here? UID staging CLR2 payload. Okay, so that's good, and it's generated our say like it's been able to reference the stuff off disk. What does this say here? PG undefined column error. Column payloads workspace does not exist. Select payloads from payloads. Well, well, well. This is something I have never seen before. How fascinating. I'm wondering if this has something to do with some recent database changes. And I haven't actually updated them recently. Maybe Brent, the Naders, or Pierce can point out what's going on. What are we looking for here? Where payloads. Interesting. So workspace ID does not exist. Haven't seen that before. I think what we might have to do. That's new. I probably just need to rebase. We fixed that at month 2. Yeah, I need to rebase. That's pretty much what that is. All right, so let's add our current stuff. Interim commit while rebasing. And I will adjust this down the track. Okay. Can't see anything that's changed there, really, hey? Alright, so now I need to do the rebase magic. How does that work again? Git. Do I need to be on the branch I'm rebasing? I need to let's Google that. Oh no, Brent's a Git wizard, and it's been ages since I've done this. It should just be a Git rebase. Bugger it. Let me just fire up Firefox. Come on. Pretty much that, yeah. It's been such a long time since I've done rebasing, and I know that sounds terrible. I'm awful. And I probably should rebase more than I do. I tend to just merge, but I do want to rebase this and play straight back over the top. Yeah, we know. We know what it is. Just show me how to do it. Check out each branch. Check out copy options, advanced rebase. We don't want to advanced rebase. During playback, should be discarded final information. Here we go. Git rebase interactive base. This rebase is the current branch onto base, but uses an interactive rebasing session. That's what I want. That's what I thought. That's what I want. Okay. So we need to git checkout CLR Meterpreter. Git rebase interactive master. Okay. We pretty much want to leave everything alone. So I think we might just keep what it is. Yeah, no, that's all right, man. Sorry. I just, like I said, I haven't done rebasing for ages, and I just thought I'd make sense. So for those who don't know what we're doing, we have a series of commits that we have added onto master, right? So the original master branch has gone off in this direction. We, at some point, we did this. So this is our CLR Meterpreter. And we've gone off and done our own thing this way, right? The problem is underneath us, master's got up to here. We call it the new head. And so what we want to be able to do is take all of the commits that we've got and just play them on top of the new head. That's effectively what we're doing. I'm the Fat Man. Welcome back. It's good to see you again. How are we doing? We're all doing great. How are you? So yeah, that's all we're doing. We're basically just trying to replay the commits on top of the old master, and that's what rebasing is allowing us to do. So let's see what happens. Did I type that right? Yep. It's a long passphrase. 5 out of 5. 6 out of 6. I know I messed that one up. Hello, I'm Hacker. Bugger. Almost got 7 out of 7. There we go. Excellent. So hopefully now if we spin up MSF console, we should have all of the bits and pieces that we had before. Ugh. I'll bet you it says update. Yeah. God. Gem install bundler. Bundle install. Ah, okay. This is the the lock file issue. Yeah. I'm Hacker. If you're here to learn, then you're in the right place. It's that simple. Righto. Recording? No, I'm not recording it. I'm building it. Yeah, I did, but Rex Arch hasn't changed, so it shouldn't be a problem. Oh, recoding it. No, I'm not recoding it. I'm building another implementation of it to run on the CLR. So have a look at, if you type bang what into the chat, it'll tell you what we're striving to do. Okay, so let's just see what happens when we do this again. Ooh, there we go. That's a bit better, isn't it? Load stage. So what I want to do now is we want to go to HTTP transport and see if the wrap function gets called. Ah, would you look at that? So it worked. We actually were able to read the stage, and as you can see, we are running the current. If we look at the modules, you can see that we are actually running. Where is it? Metserve. Metserve is running. That's pretty cool, huh? That's pretty exciting. I love it when things just work. So that's a really good sign. I'm Hacker. So, yeah, look, I'm pretty intimate with Meterpreter for one reason or another. And so this is a case of us looking to build another implementation that we can run inside .NET applications. That's basically what the go is. So, but yeah, definitely agree. Meterpreter codebase is pretty nice. It's also horrible for different reasons. But yeah, I'm confident that we have the tools and the knowledge to move ahead and correctly implement. So. Righto. Half an hour to go. I've got to stop at 10 o'clock because I have work to do, so I've got half an hour. But this is really promising. Now, the one thing that I need to be super conscious of is the way that we're routing packets. Now, if we have a look at what the server currently does when we run, you see, like, this is responsible for checking the session expiry. And while we're actually, the higher part is responsible for looping through, reading packets and parsing and processing them. That's what this dispatch packet thing actually, sorry, not dispatch packet, where is it, dispatch loop, or where is it, packet dispatch loop. So it checks the session expiry, tries to receive a packet, excuse me, and in doing so then creates a response, figures out what it needs to do, and then when it gets a response, it will behind the scenes magically dispatch the packet down the current transport. But because TCP and HTTP are so different, the idea of receiving a packet is completely different, right? So here what we're saying is if we don't get a request off this receive packet call, then we've got to move to the next transport. That's effectively how we've got it set up logically at the moment. So we need to basically have this receive packet function in HTTP reach out to the URL and make use of the existing URL. Now we do have some quirks as well. When we get to the point where, like, let's say down the track when we patch URIs, we need to be able to support that. When we get to this point, this configuration, actually we don't even know whether this configuration contains all the bits and pieces that we want. We should absolutely check that, shouldn't we? We have another follower. I'm Hacker. Thank you for the follow. I'm Hacker. That's very, very kind of you. New to the stream. Someone's just donated. I've just had my very first donation on Streamlabs APS from Phyla. So, Phyla, thank you very much for your donation. That's incredibly kind. Thank you very much. Wow. What a lovely gesture. You are the very first donator. You are a legend. Thank you very much. Super kind, mate. Super kind. Very, very nice of you. Thank you for that. Let's just set a couple of breakpoints here. I just want to see if these things actually get hit. Okay, so the config is coming through. Is it parsed? Comms timer. Yeah, look, it's got all the URI related bits in it. That's cool. Which means... let's see if we get all the bits and pieces out of here. So proxy host, proxy, there should all be blank. User agent should be set though. Oh, look at that. Cert hash is blank. Custom headers are blank. Phew! It does actually work. How incredibly exciting. Okay, so that means that the not implemented exception right here is the thing that it's currently breaking on, right? Boom, there we go. Wow! That's gone way better than I expected it to. How exciting. It's a day of excitement, isn't it? Right, so to keep things pretty simple, what we're going to do to begin with is we're going to go this.webclient.download. Now, what are we getting? We're always going to be downloading TLV packets, right? So we're just going to go download data. And we're going to use the same URI, so this.config.URI. We should be able to use the URI object itself. So we should be able to pull out, like, we'll call it the TLD data at this point. And if we look at what TCP does, what is it actually doing? It creates a new packet with a reader, which is a reader, so to speak. So what we need to do is basically do this. We can go using what does the packet take? It takes a binary reader. Okay. So new binary reader. It takes a stream as input. Okay. So what we also need to do is go var memstream equals new memory stream. You know what we could actually do? I wonder if we can somehow get, instead of doing it this way, can we reference the web client and say, give me a stream instead of download data? So maybe we can go download. I'm just trying to think, rather than pull everything, like serialize everything into an array and then use a memory reader to parse the array, can we actually pass the stream directly in? But I don't know whether we can using the web client directly. Open read. That returns a stream. Opens a readable stream for the data downloaded from a resource with the... Okay, so if we call open read, we can give it URI. Sorry, this.config.uri. So this will give us a stream. So maybe what we can do once we've done that, we can go using var, let's go TLB stream. Then we can avoid the memory stream, right? And we can pass the TLB stream straight to the binary reader. And then we can return a new packet, give it the reader and the packet encryptor. Oh, would you stop doing that? Packet encryptor. And we're done. That's cool. If it works. Colonel Smith is old and still trying to figure out how this crap works. Tell me about it. No, mate, I'm not on a Commando VM. I am just on my custom-made Windows 10 desktop that I use for developing on stream. Sorry, just got a message behind the scenes. Okay, so let's see if this works. Exception has been thrown. What does it say? Not oh yeah, you know what I need to do? I need to build it first. Because the build process, once built, takes a copy of the binary, shoves it on a share so that Metasploit is able to serve up the right version, etc. Ooh. Come on. That didn't work. Source array was not long enough. So the TLV packet itself should still work, right? Let's have a look at what that data is when it comes in. Okay, so according to this, if we look at the header, our XOR key is 4 bytes, 5C, and the header, what does the header look like now? All the zeros. Okay, that looks fine. What a great song. Ah. Can we actually do this? Can we seek on the current stream? Yeah, we can. Oh, it's because it's... Okay, yeah, that's fine. So, encrypted flags, bytes to read. That looks fine. Packet type is a request. Packet body. Encrypted is false. It worked. Oh, that's because I hit F5, and then as soon as we generate a response, we don't have the means to post it back. But how cool is that? We actually have a request packet that came in, and it's got TLVs and everything. Look at that. Method, request ID, public key. So that's going to go off and negotiate TLV encryption. Winner. So now we need to do this. We need to basically just send it back, right? So this .web client dot. Now how do we open write? Opens a stream for writing data to the specified resource. upload. What does that do? Uploads a data buffer to a resource identified by a URI. We don't want to upload file, we just want to upload data. Maybe that's it. This.config.uri response packet. It can't be that easy, surely. Now, we do have a couple of issues we've got to manage. Now, right now, we just literally try and read data in. But what we should do is we need to have, we need to reach out and handle the case where we don't actually get a packet back. And so we will be doing some magic in here. But let's see what this does. Source array was not long enough. Am I going to get that every time I do it without breaking? I probably am. Maybe what I need to do is just cheat. Don't know where it's breaking. Ah, it's breaking there. Header. Okay, so that didn't actually read all the bytes. Is that because it's basically doing exactly what I'm trying to avoid? Okay, so here's what I'm going to do. I'm going to do this. Let's go TLV data equals this. Dot. I'm going to have to do this anyway, I think. Download data this dot config dot ri. And then what we'll do is we'll wrap this in a memory stream. New memory stream TLV data. And we'll let that go as it was. However, we want to go if TLV data.length is greater than 0. Because we may find that there's cases where we don't actually get information out. In fact, you know what? Let me just quickly change that back. Because we need to get to the point where we go, okay, if we don't get any information out of our GET request, like it just comes back blank, then we want to wait and then loop again. So let's see what this does. I'm going to leave that send in there. Okay, our TLV data is blank. So now I want to loop. Let's just see what MSF thinks is going on. Oh, look at that. So, what we should do is go while I'm gonna actually no, let's leave that as let's go new byte 0. I know that doesn't make sense, but it will. So while TLV data.length is 0, we want to continue to loop. Okay. But we actually want to have the timeouts in there. Maybe I'll go back to what we had before and do the loop here. So while TLV data.length not TLV, TVL. Just wondering why that wasn't working. Length equals 0. We basically want to have a timer, right? We do like an incremental back off up to a certain amount. Like if we have a look at what the native version does, I've got to remember exactly where this is. Let's just quickly duck into, where are we? Payloads, Meterpreter, source, server, win server transport, or win HTTP. There should be like an incremental backoff packet read thing going on. Validate response, cert hash, packet transmit, packet receive. Here we go. That's reading the data off the wire. Here we go. Oh no, that's not it either. So whatever invokes this is what we're looking for. Right, so it's in the same file, just here. Righto, here we go. We've got this delay. So the delay starts at 0. And then as you can see, we've got a counter as well, which starts at 0. And then every time it fails, we increment the counter. So we basically need to do the same as this, right? Just skim through your video where you explain why you chose this project. Cool, thanks man. So we basically want to replicate this. So we start with a delay of 0. And we start with a fail count of 0. So what I'm going to do here is I'm going to do something slightly different. Actually, you know what? I'm not. So if it fails, then we want to 10 times fail count, and then fail count increments. Yeah, and then we sleep for at least 1 second. Oh, sorry, and what's that? Up to 10 seconds. All right. So we want to be able to go, what are we looking to do here? We go thread system.threading.thread.sleep milliseconds. So math.min of, basically what this is doing is making sure we cap at 10 seconds absolute max when we're receiving packets. Is delay what we use? Delay. So that's us doing the incremental backoff thing in the same way that the native version does it. So TLV data is coming out. Oh, that's actually got content this time, which is interesting. Ooh. What happened? Did that actually work? I'm assuming it didn't work. How far along are you? That's a really good question. I think for the core functionality, we've got a fair bit of it done. The big stopgap right now for us is getting the extra transport related bits done and handling the generic notion of channels. Once we've got channels in, we can do file reads, port forwards, shells, all that sort of stuff. So once we've done that, we've unlocked that. We'll probably end up implementing all of the channels that we've got available, and then we might be at a MVP. So that's the plan. No, so we're going to have a chat about that. Migration. Do we spin up a native when we try and migrate, or do we spin up an instance of the CLR using an approach like PowerPick? I don't know at this stage. That's the short answer. I don't know. We'll have to see. But it's a really hot topic. Now, what I want to do is make sure that the request going out is actually a post. So I think the problem that I've got right now is, let's go exit -y, and let's open up the for handler. Oh, what happened here? Yeah, load. Now I want to, for every packet that comes in, I want to check it. Either that or we could set up a proxy and I can look at it too. So yeah, about 100% gonna try this when it's ready. Awesome, thanks man, I appreciate that. Once we've actually got to an MVP, you know, the amount of testing that's going to be required to make this work the way we want it to work is going to be pretty significant. So any testing and feedback and whatnot that you want to give would be fantastic. So where are we again? Go back to here. So my concern right now is, let me just kill this session for a sec. I want to make sure that the handling of, oh, it could be the TLB crypto thing. That's what happens first, isn't it? So, oop, can't type. Find crypt. Where do we put that? Packet. I want to negotiate TLB encryption. This one here. So, no connection. Oh yeah, I've killed off the listener. I'm dumb. You're working on a remake of Mimikatz as well, but the dependencies makes it a pain. Oh yeah, yeah. Reworking Mimikatz, that's a huge job. Huge job. Okay, so we know that we're able to negotiate encryption. So we're actually handling the packet correctly. We should end up in here with the encrypted nonsense. The question is, did that actually go back and do its thing? Now, yeah, so we're unable right now to determine. Ah, look at that, it did receive the packet. It thinks it's encrypted, so we actually did get a response. Isn't that interesting? Okay, so what is it that we're doing wrong? Is it a threading related issue? Because if it is, then maybe we can't use the same web client to upload and download at the same time, at which point passing the web client through is probably overkill. Either that or we just need to lock or have something completely different. Maybe what we can do here is, because we know we're only going to be receiving on a single thread, but we're going to be sending on different threads. So is there a way of going this.web client dot, like, is there a way of copying it? New system.net.web client. Can we create a new instance? So we effectively want to do is, like, I want to be able to clone it for sending, or we can just create a new one. So maybe that's what the problem is. Now I'm going to need to copy a lot more stuff over. I can make sure that all the proxy bits and whatnot are in, but I'm wondering if that's going to make the difference, because if we are using one to receive, then maybe we can't use the same instance to send. And because we could be sending a bunch of packets at the same time, I want to make sure that we are, like, we can have different instances for when we send, but only that one instance to read. See what happens now. Okay, so now it thinks it's not encrypted. That's interesting, isn't it? We're probably going to have to do some packet level debugging here. Because we didn't really do anything special inside our initial program. We just had the URI and that was pretty much it, right? that actually getting hit? Should be getting hit. It's like one packet goes out and then that's all we get, right? Oh, is it because we're effectively waiting on a timeout? So we send, and now nothing's going to happen. Okay, I think I might know what's going on here. So let's just watch this. Okay, so we receive a packet, blank. Yeah, okay, so we're basically sitting here with this fail count going through the roof. The question is, why is it that we are not seeing the second packet come in? Oh, I know why. We need to read this in again. That was so dumb. So yeah, every time we loop, we then need to try and read again. So we should see multiple packets this time. There's one. There's another one. Oof. Well, at least this one thinks it's encrypted, so that's a good sign. So that has got the fail count going through the roof. So let's just go... so this has got... You see how this has a check-in? See how it's going up? So what we need to do... There's probably a piece that requires us to sort of reach out with a heartbeat along the way. There you go. So the check-in is actually working, right? But for some reason, we're not actually handling the packets correctly. So let's interact with that and go... Ugh. So standard API clearly hasn't been deployed. That's interesting, isn't it? It works. It works. Why is it not doing that up front though? So we've clearly got an issue wiring it on the MSF side. So my feeling might be that when our new session comes into the CLR things, we don't do the correct wiring on that side that forces standard API and priv and all those things to try to be loaded. But as you can see, like the transport, it actually works. It's doing exactly what we want it to do. So my next question would be this. Let's go. This dot. Another follower, Etherpunk. Thank you for following. Getting close to my limit here, guys. I'm going to have to bail very shortly, but let's see if this behaves. No. Web client does not support concurrent I/O. Why didn't you say so? So we just need to make sure that we wire in all the proxy stuff. Thanks, man. I appreciate that. Feedback is very kind. Alright, so that's actually doing what we want it to do, right? You can see the check-in stuff is actually behaving itself, and the incremental backoff should be doing its thing. 1 second. What was the most challenging aspect of implementing this in C# compared to native? So far, the most painful parts have been pretty much having to deal with native functionality via pinvoke rather than having a .NET abstraction over the top of certain things. So that's, I'd say, has been the most pain. Everything else has actually been scarily easy. So yeah, use standard API. Okay, so that's clearly our issue. For some reason, standard API is not automatically being loaded. We need to look into the Ruby wiring to see why that's the case. And I think that'll be the topic of the next stream. Colonel Smith has followed me. God, surely you're sick of me by now, mate. Can you expect a remake in HTML? No. Certainly not from me. So what we'll do is, I think it's 10 o'clock and I have work to do, so I'm going to stop there, but we'll resume this from where we currently sit. So just to recap, we put some simple wiring into MSF to allow for HTTP transports. We've basically plugged a few gaps in the HTTP transport on the Meterpreter side. And we just had to figure out a couple of little quirks, implement the incremental backoff. And we're at a point where, for the most part, it's actually working. So we just need to make sure that on the MSF side, the wiring around CLR implementations of Meterpreter is actually being done properly, so that when a new session is created, we go ahead and wire in standard API and various other things automatically. And then from there, we're in a good spot. Another follow, Bradley Security, thank you very much. All these follows makes me feel good, hits me in the feels. Yeah. So yeah, that's what we're going to do on our next stream. Now I don't know whether I'll be doing that in the evening over the next few days, or whether I'll try and do another morning stream just to keep mixing it up. But what I'm going to do is I'm going to pause it there and reconvene and finalize this on the next one. So thank you very much. I'm so sorry, Raleigh, that's so kind of you. But yeah, it's 10 a.m. and I snuck a sneaky one in this morning, and I really need to get some stuff going on. Yeah, it was good. It was really good. So it was great. But thanks very much to everyone for coming on and showing their support and throwing in the comments. And it was really nice to have people on and having the discussion. So very much appreciated. Hope you guys have awesome evenings, etc., or mornings, wherever you may be. And until next time, as always, hang on, I've got to show my face for this. Where are we? Be good to each other. See ya.